So in this video, we're going to be learning about tangents, secants, and normals, really getting closer and closer to what the real identity of what calculus really is, which is really just a rate of change. So to find the secant, the slope of a secant line, this is the formula you're going to use, and this is nothing different than finding the slope of a linear equation with rise over run, except now for a secant, which is right here, you're just going to find the rise over the run of that of the linear equation that goes through the 2 points of your curve. Okay, so that is a secant. Now, what starts to happen here is to get the rate of change at a certain point on a function, like this one right here, we want to find the tangent line. Now, to find the tangent line, we're really trying to find a secant line where the difference is almost nothing. And that's why we come to this equation right here. Okay? We're trying to find the function plus h minus the other function all over h. And there's like an imaginary minus 0 here, just to kind of compare it to this one right here. Because this f of b is right there. This f of a is right there. B is h, and a is actually 0. So there's like an imaginary minus 0 here. These formulas are the same, but the difference is for instead of a secant line, we're trying to make it so that there is no space. That's why the limit is going to 0. That just really means that there is no space in between. Okay? And then this is just really what we call the definition of a derivative. And you can use this equation to find the slopes of all tangent lines. Okay? There's an alternate form, which this one looks a little bit more closer to our secant line, but it's the same idea. We're just trying to make that secant line as tiny as possible, and that's what we get from here as well. Okay, so this one lines up a little bit better just looking at this, but that's what an instantaneous rate of change is. We're just trying to find the tangent line at a certain point, and to find a tangent, we actually have to find a secant, but a secant with really 0 length going from one point to the other. Okay. So what does this look like for problems? So what we're going to do here is we are going to find the derivative using the definition of the derivative here. Okay. So what we're going to do here is, first off, here's f of x. That's totally good. And now what I need to do is I need to find what f of x plus h is. So all I'm going to do right here is write this down. F of x plus h. What does that actually equal? All I'm going to do is replace this x right here with x plus h. So it becomes 3x plus h plus 1. And that's f of x plus h. Okay? So now I'm going to put this all in my formula. My handy dandy. What's f prime of x? Well, it's the limit as x approaches 0 of this 3x plus h plus 1 minus 3x plus 1 all over h. And what we're going to do here is we are going to, well, in order to do the limit right here, I cannot plug in a 0, because if I do that for h, or this should be for h, I don't know why I wrote x. If I plug in a 0 for h, then I'm going to get 0 over 0, no good. So the best thing to do here is to multiply by the conjugate, which is going to be this 3x plus h plus 1 minus 3x plus 1. Okay. So now what I'm going to get here is, well, since these are conjugates, there's no middle terms, and I'm going to end up squaring those two last terms. So mathematically, it actually is going to turn out a little bit nicer. So it's 3x plus h plus 1 minus, oops, oh, that went away. I don't know why I did that. Minus 3x plus 1. Don't forget to, again, to distribute that minus sign all the way through. H, and then here is this conjugate 3x plus h plus 1 minus 3x plus 1. And what's going to end up happening here, I'm really hoping, is that this h is going to cancel out, and it's going to make it a little bit easier. So when I start distributing on the top, just a little bit of side work here, I'm going to get 3x plus 3h plus 1 minus 3x minus 1. I'm going to distribute that top up there. So now you can kind of see that, okay, 3x's are going away, 1's are going away. The top only has a 3h. And now those h's are going to cancel out, and I can plug in my 0. So I'm going to kind of plug in my 0 right now, so just so it's not so awful looking. So h's are gone. I'm left with 3 over, I'm going to get, oh, this should be, I don't know why I did this. Another little boo-boo here. Let's fix it. This is a conjugate. Plus, plus. Plus, plus. Okay. Sorry about that. So I'm going to get 3 over, I'm going to plug in a 0 for h. I'm going to get 3x plus 1 plus 3x plus 1. So my final answer is going to be 3 over, there's 2 of these, 3x plus 1s. And that's how you find the derivative, or the function of the rate of change of this function right here. So what this looks like is, if I were just sketch it real quick, looks something like this. So now this function down here, I can use that to find the rate of change at any point that I want. Like, let's say at this point right here. Okay, so this is the point 1, 2. Well, to find the tangent, the slope of this tangent line, I just have to plug this back into here. Okay, so if I were to do that, it looks like I would get 3/4. So this slope is 3/4. Again, I'm just plugging that 2 into here. So that's the use of the definition of a derivative. Now let's get on to some average velocity problems, which deal with secants. Okay, so if a ball is thrown into the air with a velocity of 40 feet per second, and its height after t seconds is given by this equation right here, let's find the average velocity for the time beginning with t equals 2 and lasting 0.1 seconds. Okay, so I'm going to use my secant. So I'm going to get y equals, not y, I'll just do the average velocity. So the average velocity is equal to, well, if I plug in a y of 2.1 minus y of 2 all over 2.1 minus 2. Okay. This is going to give, so this is essentially what I'm doing is the, where did I throw that? This guy right here. Okay. So I'm just finding the average velocity, which is like this right here. So what's the average change given this function right here? And then now, since this is a 2.1 decimal and get this, you literally can just plug this right into a calculator. Okay, so if I were to plug this into a calculator, I would get, I don't have one in front of me, so I'm going to use what I used before. I got this number right here, which is going to give me an answer of negative 25.6 feet per second. Let's make this decimal a little more obvious right there. Okay. So let's say find average velocity. Average is going to be the secant. Instantaneous, that's when we're going ahead and use our formulas. Now, if I'm finding an instantaneous velocity at a certain point, look at my two formulas I have here, I'm going to want to use this one if I'm given a point. If I want to find an equation, this is the easier one to use. If I need to find it at a point, then I'm using this one because it's just a lot simpler to do. I'm going to do this in different color. Okay, so let's find the instantaneous velocity at 2. So to do that, I'm going to do the limit as t approaches 2 of, and then I'm going to do f of x, which is 40t minus 16t squared minus f of 2. Okay, so I'm going to plug in a 2 now. So 40 times 2 minus 16 times 2 squared all over t minus 2. What's going to end up happening here is lots of math here. I was just trying to see if I could simplify this real quick in my brain, and I cannot. So I'm going to have to that's going to be 80 minus 464. 80 minus, this is going to end up being 80 minus 64, which is going to turn into 16. Yep, so this is going to turn to 16, and then I'm going to be able to factor all this. So limit as t approaches 2 of 16 plus 40t minus 16t squared all over t minus 2. All right, so that's all there. Okay, so what I'm going to do now is I'm going to factor the top. It looks like I can take out a 16 to be nice and easy. And then, no, 16 doesn't go into 40. I'm going to take out an 8, so this looks a bit nicer. So I'm going to go a little bit into over here. So I'm going to get the limit as t approaches 2 of 8, 2 plus 5t minus 2t squared all over t minus 2. I bet you I'm going to have to factor out a t minus 2 on the top. Just by looking at it, I'm just using some context clues here. So t goes to 2. I'm going to get 8. I bet you're going to be able to factor out a t minus 2. And if I do that, tell you what, make this a negative 8 in front, so you're not there. Right here, it's going to flip all these signs, make it a little bit easier, so I know that's going to be a 2t minus 1. Sorry, a little quick factoring there. This, believe it or not, is going to equal that. This should be a plus right here. I did not need to change that. Just took out a negative, and I just real quickly flip this, factor this. I'm going to get t minus 2. Now those minus 2s are going to cancel out, so I'm going to be left with the limit as t approaches 2 of negative 8 times 2t minus 1. And now I'm ready to plug that in. So when I plug in a 2, I'm going to get negative 24 feet per second. Okay. Sorry, lots of algebra going on there. Hopefully didn't trip too much in there. The main idea here is just getting this equation right here. You use a little bit of algebra. And if you notice, the instantaneous rate and then the secant, which we just did the secant just a little bit after 2, pretty darn close, which is about right. Okay? Don't worry, these problems, not so long. Let's find the equation of a tangent line at 2. So tangent, equation of a line, by the way, is y minus y1 equals slope x minus x1. Okay? So I have the y value. I'm going to need to plug that in to get my x value, okay, which I did before because I got that to be a 16. Okay, so I already did that. So I'm going to get y minus 16 equals the slope, which is negative 24. X minus, and I'm looking at 2 because I'm really doing x comma y coordinates. Okay, so I got 2 comma 16 by plugging it back into there. That's it. That's all you need to do, nothing else. Okay, so that is the equation of, let's just play pretend here. That would give us an equation of that tangent line. So that's what we're doing now. So that tangent line that we draw it to is this guy right here. Now, normal. What a normal line is, and I didn't really talk about it. I'll bring up that previous thing right here. The normal, okay, is what's perpendicular to the tangent. So to find the normal, all you do is it's negative 1 over the slope. That's it. So my new slope for my normal is going to change. So it's still y minus 16 equals something x minus 2. I'm going to change that. So I'm going to make it a negative. Well, it's already negative, so it's going to become positive. So it's 1 over 24. And that is and that's going to be everything here. And I'm kind of a lot thrown at you. First part of this unit, super important. We'll learn shortcuts along the way, but that is going to wrap up this video.